In this video, we are going to discuss the linked list data structure and the algorithm to insert nodes to it. We will see how to insert nodes at the end of the linked list. I will give you a line-by-line simple explanation of all the code that we will be writing in this video. Watch this video till the end as I will also show you visually how to construct logic while writing linked list algorithms. My name is Aditya Shenoy from Brainy, where I make programming simple and fun. YouTube statistics show that some of you who watch my videos are not subscribed to this channel, so if you end up liking this video, please consider subscribing. It is free and you can always change your mind in future. Before defining the linked list data structure, we have to first create the node class. So I will create a class, I will name it as node, and inside this I will initialize the constructor by defining the _init function. Apart from self parameter, it will have data parameter. So I will set self.data is data, and as this is a single linked list, I will have self.next is none. So our node class is ready. So we can start writing our linked list class like this. Here also I will define the constructor just like the previous one. I will define the _init function, and inside this I will initialize self.head. This pointer will initially be none, and as we add nodes to it, as we add nodes to linked list, this head will point to the first node in the linked list. So that is that, and so that we can print the linked list object directly by using the print function, I will define the _string function so we can visually see how our linked list looks like. So _string function and a self parameter. I will initialize a result list like this and initialize a node variable to self.head, and while there are nodes in the linked list, we will append to the result the string representation of node.data, and then we will proceed with the next node. So node is equal to node.next, and after all the nodes are processed, we will go out of the while loop and we will return arrow separated list of nodes. So the result has all the data of all the nodes, and we will join them using an arrow so that we can visualize the linked list. We will see how this string function will work once we start printing the linked list. Now we can start writing the function to add nodes to the linked list. In this video, we will be seeing how to add nodes to the end of the linked list. So I will define a function and name it as add last. And apart from self parameter, it will have data, like what data do you want to add to the end of the linked list. So first we will create a new node. So I will name a new node variable and use the node constructor, the node class that we have defined over here, and pass the data to create a new node. Now there are two cases. To add the node to the end of the linked list, we have to manipulate the next pointer of the current last so that it points to the new last. But there is a boundary condition, that is when there are no elements present in the linked list. And so when we add this data to the end of the linked list, it will become the head of the linked list. So there are two cases over here. So we will define them one after the other. So first we will see the normal case, like if there are some elements already present in the linked list, what will happen? In that case, self.head will not be none in that case. So self.head, if that is not none, we have to find the last pointer, last node, so that we can link it to the new node. So I will initialize that last pointer to self.head, and while last has next elements, because last element's next pointer will point to none value. So we have to iterate a while loop until we reach a node whose next value is none. So we have to iterate while last.next exists, and we will do last equal to last.next like this. And after the while loop breaks, we will have a last pointer whose next pointer points to none. So we can easily do last dot next is new node, and that will do the entire thing. So new node's next pointer is already pointing to none value by its constructor, and the current last pointer next pointer is pointing to the new node. So you can visualize the linked list that will be created. We will see how this code works by doing a dry run once we complete this code. What will happen if this node is the first node that is being inserted in the linked list? In that case, we will have an else clause, and we will simply point self.head is new node. We don't have to do anything else because new node's next pointer is already pointing to none value, and in either of the cases, as this node new node will be at the end of the linked list, self.next, that is last node's next pointer, should already point to none value. So we have to see there are two cases only depending on the last pointer. Let's do the dry run of this code so that we understand how visually the linked list will look like. So initially there will be a head pointer, and that will point to a none value. So by default, self.head will point to none value. And when we run, suppose we add the first element as 1, that is a node having a value of 1. In that case, the first line will do a construct a new node. So I will denote that by a box like this, and so a new node will be created, and by default, by the constructor, its next pointer will point to the none value. So that is done, and we will see if self.head is done. Here the self.head is pointing to none value, so it will skip all the if condition statements, and it will jump into the else clause. Else clause states that self.head will point to new node, so this pointer will now point to this node like this. And if we rearrange this, this will create a linked list with one node. So that is simple, right? Now the non-boundary case. So what if we want to add the next node? That is, suppose we want to add a node 2 in this linked list at the end of the linked list. In that case, again we will start with the first line, that is new node is node data. So a new node will be created with the data 2 like this. By default, its next pointer will again point to the none value. So that is done. And now in this case, self.head is not pointing to a none value, so this condition will become true. So last will point to self.head. Now a new variable will be created, last. The last pointer will point where the self.head is pointing. So currently it will point to node 1, and we will iterate while last has a next value. So in this case, this last node, so last is pointing to this node 1, node's next value is none, so it will not at all go inside the while loop, and this while condition will become false in the first try itself. It will not enter the while loop, and after the while loop, last dot next, that is uh, this is the last pointer, so its next pointer will point to, so this will point to the new node like this. And if we rearrange this, you can see that the linked list has been created. This last pointer was a temporary variable, so that will get deleted. So the final linked list after this execution will look like this. So you can see that the node 2 has been successfully appended to the end of the linked list. We can see how the node 3 is also added to better understand this. So the first line states that a new node will be created with the data. So in this case, we will pass a data 3, and if self.head. So self.head is not pointing to a none value, so these statements will be run, and a last variable, last pointer will be created, so like this, and it will point to this self.head initially. I will move this and move this over here, and the first line has been executed, so last is pointing where the self.head is pointing, so that is done. While last.next, so last is this, its next value is not none, so it will enter the while loop. Last is last.next, so this pointer will now move to this pointer, this node. So last will point to node 2 now. Now it will again check last while last.next. So now this last node next value is none. So it will not continue the while loop and it will exit out of the while loop. Now last.next, that is this node's next value, will now point to the new node that we have created, that is node 3. And I forgot to mention this, but when we create a new node, its next value by default points to the none value by this constructor. So if we rearrange this again and delete all the temporary variables, that is the last variable is a temporary variable over here, so we will get a linked list which looks like this. So head is pointing to the first node always, and the new node has been appended to the end of the linked list. So now we have seen how visually this linked list add last function works. So we can test this code by defining a variable linked list and create a object of linked list class. It will not take any parameter, and first we will print the empty linked list, and after this we will add data 1 to the end of the linked list. Then we will print the linked list again, and I will copy these two lines two more times to add data 2 and data 3, just like the example that we have just visualized. So first node 1 will be added, then node 2 will be added, and node 3 will be added. Let's see by running this code. Yes, it is correctly being printed. So initially there you can see a blank line, that is due to this line because we are printing an empty linked list. Then node 1 has been added, then node 2 has been appended to the end of the list, and then node 3 has been appended to the end of the list. So this is how you write the code for linked list data structure and algorithm to insert nodes to the end of the linked list. The time complexity of adding node to the end of the linked list is linear, that is O of n, as we have to traverse the entire list. We can reduce the linear time complexity to constant time complexity if we store the end pointer like we have the head pointer. Adding nodes to the end along with deleting nodes at the beginning will follow the first in first out mechanism, and thus queue data structure can be created using these functions. So by understanding the linked list data structure, you can write code for queues as well. And queue is very useful in various applications. If you ended up liking this video, please press that like button, comment any feedback that you have for this video or this channel, share this video with your friends. The code that I write in all my videos of this channel is available in my GitHub profile, whose link is in the description. You can connect to me via LinkedIn, whose link is again in the description. If you want to see a line by line explanation of data structures and algorithms like this, check out the playlist over here. If you want to learn Python built-in functions along with various Python features, tips, tricks, and real project examples, then check out the playlist over here. If you want to see a hands-on game development project, check out the playlist over here. And I will see you in the next video.